Finding the measures of arcs. So in a minor arc, it's just the same measure as the central angle. So in this example, if your central angle is 60 degrees, and here's point A and B, then you know that your minor arc is also 60 degrees. So the measure of arc AB equals 60 degrees. Arcs are measured in degrees just like angles. However, a major arc is the difference between 360 and the associated minor arc. So in the same example, the major arc, and here's point C. The major arc I'm going to go over in pink. This major arc, ACB, is equal to 360 degrees. Remember, there are 360 degrees in a circle, so that's where the 360 is coming from. And if you take away your 60 degrees from your minor arc, your associated minor arc, then that will give you the measure of your major arc, which is 300 degrees. So arc ACB, that measure would be 300 degrees. You can also add arcs, just very similar to the segment addition postulate. There's the arc addition postulate. So if you add 60 degrees for arc AB plus 300 degrees for arc ACB, you'll get 360 degrees total. Congruent arcs are arcs that are in the same circle or in congruent circles that have the same measure. So in this circle, if this arc is 70 degrees and this arc is 70 degrees, we know that these two arcs are congruent because they're in the same circle and they have the same measure. However, in this other circle, we'll say this arc is 70 degrees. These two arcs are not congruent because they are not in the same circle, and these two circles are obviously not congruent. This circle is much larger than this circle. You might also be given a radius. We'll say this radius is 5 units long and this radius is only 2 units long. So these circles are not congruent because this radius is much larger than this radius. So even though these two arcs have the same measure, they're both 70 degrees, because these two circles are not congruent, these arcs are not congruent. And we have a few properties. These properties, basically if you know one, then you know all three. So first, if central angles are congruent, then their chords are also congruent. If two chords are congruent, then their arcs are congruent. And last, if two arcs are congruent, then their central angles are congruent. So they kind of go in order. I'll give you an example here. So we'll say this is your central angle, and this is your central angle. These two central angles here are congruent. So based on number 1, they have congruent chords. So you might have a chord drawn over here. So you would know that these two chords are congruent based off of number 1. Number 2, if you are given that the chords are congruent, so if you know these two chords are congruent, then you also know that their arcs are congruent. And last, if you know that their arcs are congruent, then you know that their central angles are congruent. We'll do an example over here. So you are given these two arc measurements, which are 2x degrees and x plus 40 degrees. You know that two chords are congruent, therefore based on that theorem, their arcs are also congruent. So you would know that 2x is equal to x plus 40. And to solve for x, you subtract, and you would get x equals 40. The next theorem says that if a diameter of a circle is perpendicular to a chord, remember perpendicular means 90 degrees. If it forms a 90-degree angle with a chord, then it bisects that chord and it bisects the arc as well. So for example, if, let's see, we know this is a diameter because it goes through the center of the circle, and we know it's perpendicular because it forms this 90-degree angle. Therefore, we can conclude that it bisects this chord, meaning these two measurements are equal. So if this segment is 5 units, then you also know that this one is 5 units. You can also conclude that these two arcs are congruent as well. Conversely, the next theorem states that if one chord is a perpendicular bisector, so perpendicular means 90 degrees, and bisects means that it cuts it in half. So if it's a perpendicular bisector of another chord, then the first chord has to be a diameter. So going over to this example, you would know that it's a bisector because these two segments here and here are congruent, so this long segment is bisected. And you also know that it's perpendicular because of the 90-degree angle. Therefore, you know that this segment is a diameter. And last, if in the same circle, or two congruent circles, two chords are congruent if and only if they're equidistant from the center. So because this is an if and only if statement, there are actually two statements here in one. The first statement is if two chords are congruent, then they are equidistant from the center. And the second statement is the converse. So if two chords are equidistant from the center, then you know that they're congruent. So you get both of these statements from this one theorem because of the if and only if. So for example, here we are given two chords, and we know that they're equidistant from the center because this segment is 9 and this segment is 9 units. So these two chords are equidistant from the center, therefore we can conclude that this segment is congruent to this segment. These two chords are both congruent now. So PR, and we'll name this one S. So you know segment PR is congruent to segment RS. And for this example, you know that, I'll give you that, let me see. I'll give you that these two chords are congruent. So I'll tell you that this chord is 10 units, and I'll say this chord is also 10 units. Therefore, you can conclude that the distance would be, if I told you this distance was 5, then you could conclude that this distance is also 5 because they have to be equidistant from the center. So you're given that two chords are congruent, so you know that they're equidistant. Here you're given two chords are equidistant, so you know that they're congruent. So for example, we are asked to find the value of x in this diagram. So let's first look at this chord is 36 units long. And how long is this chord? We'll do 18 plus 18 more is 36. So this chord is 36 units, and this chord is 36 units. Therefore, the two chords are congruent. So, you know that they're equidistant. and you're given that this distance is 16 units, and this distance is x units. But you know that they're equidistant, so 16 should be equal to x. So x would actually equal 16, that's your answer. And that concludes the 10.2 notes.